Hey there, how you going? Thank you so much for clicking on this video. Today I'm going to be covering how to approximate pi using the Leibniz method. You might need to do this for a computer science class at university, or you may just be interested to learn, but either way this video will be for you. I'm going to try and make it as simple as possible. Of course, this is assuming that you understand how Python works, so I'm not going to be explaining modulus signs, while loops, if-else statements, variables. And we're going to be creating a function in Python to do this. So yeah, so if you don't understand something, feel free to drop a comment below. However, if you're kind of a bit confused on the syntax of Python, I definitely recommend that you just watch another video first to get yourself up to speed. There's plenty of great videos out on YouTube about basic Python stuff. So, Leibniz was a German mathematician of the 17th and 18th century, and he created this series that I'm going to show you. So he created this series, and back in the day they used to approximate pi by having a big circle and splitting it up into tiny little triangles, and then working out the area of those triangles and doing something to that to approximate pi until Newton came along and invented calculus, and then all of that changed. So I'm not sure exactly where the Gregory Leibniz series fits in with all of that. However, it seems to approximate Python pretty accurately for my general needs. And so, yeah, so I think it's very important to gain an intuition of how pi is calculated, as this will really aid in creating this program that will calculate it for us. I think the biggest mistake people have is trying to code something whenever they've got no idea about the intuition behind it and how it's actually working. So I'm going to try and give you guys a good intuition of that, and it can all be summed up in this photo. So when we look at this series, what we can see is pi equals plus 4 over 1, so plus 4 minus 4 over 3, plus 4 over 5, minus 4 over 7. So what we can see is that all of the numerators are 4, and all of the denominators increase starting from 1 by 2. So 1 plus 2 equals 3, 3 plus 2 equals 5, 5 plus 2 equals 7, etc., etc. And if we were to label these different numbers here, these different fractions, for their place value, we would say that this is in place 0, this one is in place 1, this one is in place 2, and this one is in place 3. So from that, we can derive that this one in the 0th place is a positive, and it starts at 1. So this one in the 0th place is positive, and this one in the second place here is also positive. And this one in the 4th place here is also positive. So from that we can derive that all positive place value fractions are positive. I did not write that right. That all even place value fractions are positive. So this one's positive because it's in the 0th place. This one's positive, or maybe not because, but it is positive and it's in the 0th place. This one's positive and it's in the 2nd place. This one's positive and it's in the 4th place. And yeah, obviously I'm starting from 0 when I'm counting these guys. And so then on the contrary, we can also say that all odd place value fractions are negative. So we can see that in the 1st place, it's minus 4 over 3, so negative. And in the 3rd place, it is minus 4 over 7. And in the 5th place, it's minus 4 over 11. And we are going to assume that this continues on, which it does. So all even place value fractions are positive, all odd place value fractions are negative, and the denominator increases by 2 from 1. So when I say that, I mean it starts at 1 and it increases by 2 every fraction. So 1, 3, 5, 7, 9, 11, 13. And with that, I think we can get started in writing our code. So this is a pretty simple function. The way I'm going to write it is not very clean and neat, but that's just for understanding, especially if you're just getting started with Python. I think it'll be an easy way to understand. So we're going to create a function that's called def calculate pi, calculate pi, and we're going to give this value inside here n. Now, once we've created this function calculate pi, we're going to need to add some things, and they're going to be two variables. So first of all, we're going to have pi, which is, we're just going to start out as 0, and that is going to be our output at the end. So that's what we're going to want to equal pi, hence the name. And we're going to create z, or let's just call this denom. That's going to represent the denominator. So we're going to start this at 1. And you can see here that the denominator starts at 1, and that's why I'm starting it as 1. Okay. So next we're going to create a for loop, and we're going to create for I in range n. So we're going to run this loop n amount of times. So it's going to, the pi value is going to be n accuracy essentially, because the further along this sequence you get, the more accurate pi will be. So for I in range n, what we're going to want to do is create two statements. So we're going to have an if statement, and we're going to have an else statement. For the first if statement is going to say, if I mod 2 equals 0, so basically what this is saying is, if I is even, do what's below. So what are we going to do below? First of all, we're going to take pi and add 4 divided by the denominator. So as you can see here, 4 is constant across all of these different values in the series, and the denominator changes. So we're going to go 4 over the denominator, which starts at 1, so 4 over 1, and then we're going to want to increase the denominator by 2 every time, as we saw before. Now the other statement that we need to make is an else statement that caters for the fact, or caters for when I is odd. What we're going to do in this is the same kind of thing, except instead of a plus minus, we're just going to do a plus equals. We're going to do a minus equals 4 over denom, and then we're going to add, whoopsie daisy, and then we're going to add 2 to the denominator. And that's it, that's our function. Now all we need to do is return pi, and bang, we can try this out. So I'll print a statement. You know, I could create a doc string, but I'm just being lazy. So def calculate pi to, let's say, what's that? 100,000 points of accuracy. Oh, I have definitely stuffed something up. Let's have a look. It's good to see when you've stuffed stuff up so you can debug it and look back at what you've done. Pi minus equals denom. That's not what I was meant to do. It was meant to be 4 divided by denom. Now this should work. There you have it. If you guys have any questions below, please feel free to ask them in the comments. I'll be happy to answer anybody's questions. And yeah, give me a like and thumbs up if you like this video. And if I didn't explain anything very well, please feel free to just comment or whatever.